Now what we're doing today is continuing on with what we started yesterday, our systems of linear equations with three variables. So when we look at this first one here, the first thing we need to do is determine which variable we want to eliminate first. X, Y, and Z. Now this one, unlike the last one we had, we could eliminate any one. All of them are good choices because if we look at X, well, the first equation has 1X. Well, we can easily turn it into 5X and 4X. We can multiply it by 5 to get 5X, 4 to get 4X. If we look at Y, well, the top and bottom equation already are the same. They're 1Y. So we have to pick one of them, multiply it by 5, and we get the middle. So that one's not too bad to do elimination on. If we look at Z, well, the top one is 1Z. So I could easily turn it into 3Z and 5Z. So any of the three variables, any one that we pick will be good for doing elimination first. So, yep, those are all yours. So, X, Y, or Z, which one do we want to eliminate first? X. Okay. Now, since we're eliminating X, we're going to use the top equation. We want to use or pick the equation that is going to be easiest to turn into the other two for our eliminator equation. So this one, we're going to use the top one. Now, since it's the eliminator equation, we're going to write the other two equations that we're going to eliminate X out of below it. Now, I didn't state this yesterday, but part of the reason I highlight the eliminator equation is to make sure I don't list it as one of the two we're going to eliminate X from. Okay. So the one on the left, what do we need to multiply this equation by to get the X's to be the same?
Would it be 2? Yeah.
So we have 1X, and we want it to be 5X, yes?
Oh, 5?
Yeah. So we multiply it by 5. Yeah. We're just trying to multiply it by 5. We're trying to see what number do I multiply it by so that the number in front of X is the same. Now, there are some books or some resources, if you look these up, that will say we want the number and sign to be the same so that we can subtract every single time. Or we always want the signs to be opposite, so we add every time. But really, my main focus when I do these here is just getting the number the same. Because 5 times X is 5 times Y is going to be plus 5Y. Plus 5 times Z is 5Z, and 2 times 5 is 10. Because I know for the most part, just keeping track of signs is already challenging enough as it is, let alone trying to throw in that step here. Any questions on this so far? Now to eliminate X, to remove it from this equation, would we add or subtract the 5X's from each other? 5X minus 5X is 0, just like we wanted. So that means we're going to be subtracting. So 5X minus 5X is indeed 0. 5Y minus 5Y is, it's also 0, okay. And 5Z minus 5Z is 0. So this entire side became 0. Now I don't list them out as 0x plus 0y plus 0z because that's just all just 0. We can just write 0. Now let's look at the other side. 3 minus 10. Is this a true statement? Is 0 ever equal to negative 7? No. So this here is because it's telling us those two equations are, or those two planes are going to be parallel to each other. And for us to have a solution, all three have to intersect, all three have to cross. So if two of them do not cross at all, doesn't matter what the third one does. It's no solution. They're parallel. We need them intersecting. So no solution, we're done. Questions on this here?
On the question we did yesterday,
Mm-hmm.
we divided by 2 on that one, and now we're just dividing. We're multiplying by 5.
Because again, we want the x to be the same. Because we need them to cancel out. We need them to eliminate out. Because on the last one, the one from yesterday, we needed whatever variable we were eliminating first to be the same, which in that case, I believe it was 2x. So to get our 1x to be the same as 2x, we multiply it by 2. Because if we did the other side to get x to be the same as 4x, we'd multiply it by 4. Mm-hmm. So that's the end of this one here. Questions on this here? Let's look at the next one. X, Y, and Z. Another 3 variable system of equation. Now looking at all 3 of these here, if there's ever a case where one of the sets of variables already has the same number in front of it, I always default to it, because that means I don't have to do anything to it. And if we look at this here, well, we have x, x, and 5x. The next one we have y, y, and 5y. And z, we have z, z, and z. For this one here, the z's are already the same, yes? So personally, I would go on and eliminate z first, because I don't have to do anything to any of the equations. I don't have to multiply the eliminator equation by anything to get it to be the same as the other 2. Like the one we just did, we had to multiply the equation by 2 to get the x's to be the same. Here, they are already the same. But I still need to pick an eliminator equation. Which equation do we want to be or use to eliminate z from the other 2? Top one. We'll use it. And since we're using it, we can write the other 2 down. Now, if the variable we're wanting to eliminate is already matching, we can just write it in. Thank you. Try to get it away from the headset. That way, if you do go back and rewatch it, it doesn't just blow your ears out all of a sudden. So this is nice because, again, the number in front of z on all 3 is the same. I don't have to change anything to it. Now looking at the one on the left, we have negative z and positive z. So would we add or subtract? So we have negative z minus z. Negative 1 minus 1 is what? Oh, clear. Negative 1 minus 1 is, so we're canceling z. So the signs are opposite, yes? If the signs are opposite, we add. Because negative 1 plus 1 is 0. Z minus z, or negative z plus z, is indeed 0. So here, we're wanting to eliminate z. That's the one we're going after, is z this time. Yeah. I'm wanting to eliminate z first. And part of the reason I'm eliminating z first is because when we look at the equation, the number in front of each z is 1. They're already the same. We don't have to do anything to it to get it to cancel, besides add the 2 equations together or subtract them. Now adding x plus x is 2x. Y, negative y plus negative y is negative 2y. And negative 3 plus negative 3 is negative 6. And our negative z plus z is indeed 0. Any questions on the left-hand side? Because we have been doing x first, but we don't have to. We can do x, y, or z, either one. Let's look at the next one. So we have z and z. Would we add or subtract these? So z plus z is 2z, yes? We want it to be what? 0. Okay. So let's try subtracting. Yeah. So z minus z is 0. If the signs are the same, we subtract. If the signs are opposite, we add.
Yeah, that's why I said add.
You're good. Because both, we don't have to always add on both or subtract on both. We can do one or the other, or both. So here we're going to subtract. Now going left to right, 5x minus x is 4x. Negative 5y minus negative y. Well, a negative would make a. So negative 5y plus y is negative 4y. Z minus z is 0, just like we wanted. Negative 15 minus negative 3. Well, the negative makes a plus. And negative 15 plus 3 is negative 12. Questions on how we got to our two equations with two variables? We feel good with this here so far, yes? Okay. Do we want to eliminate x or y next? So we always want to go up. What can I multiply 2x by to get it to be the same as 4x? 2. Okay. Since that's easy enough as it is, we can rewrite our 4x minus 4y equals negative 12. And we're going to multiply our other equation by 2. And we distribute the 2. 2 times 2x is 2 times negative 2y is negative 4y is equal to negative 12. Questions on how we got to this point here? At this point, we can subtract because we have the same sign, 4x and 4x. 4 minus 4 is 0. Negative 4y minus negative 4y is 0. Negative 12 minus negative 12. Is this a true statement? So the answer for this one is infinitely many. There's infinitely many solutions. Now I'm not going to ask you to actually define what those infinitely many solutions are. We're just going to label it as infinitely many. Because if at any point we do get 0 equals 0, especially at the end, it's going to be infinitely many. If you get it in the second step where we have two equations with two variables, if one of these spots, either here or here, becomes 0 equals 0, go on and check the other side. Unlike no solution where we got the one side 0 equals 7, negative 7, we didn't have to check the other side. Here, if this side became 0 equals 0, go on and check the other side. See what we get. See what we get. because if one of them worked out 0 equals 0 and the other was 0 equals -7, it's still no solution. Does that make sense? Because it just means the other two are parallel to each other, or are the exact same plane, not parallel, are the same plane, and the other one's parallel to those two. Questions on any of this here? Be ready for the next one. Looking at this one here, which variable do we want to eliminate first? Y is a good choice. So why would we pick Y? They're all 2. All 3 equations have 2Y, so it's going to be the easier one to eliminate first. Now we do need to pick an eliminator equation. One we will eliminate Y out of the other 2 with. Do we want the top, middle, or bottom? Okay. Since we've picked our eliminator equation, we can go on and write the other 2 out. And since the Y values are already the same, we can go on and just fill them in. Any questions on this before we eliminate a variable out? Okay. Now looking at the one on the left, because we want to eliminate our y. So we have -2y and +2y. So -2 minus 2 is what? -4. So if we do -2 plus 2, we get, if the signs are different, we add. If the signs are opposite, if the signs are the same, we subtract. If the signs are opposite, we add. Signs are the same, we subtract. Signs are opposite, we add. So we have negative and positive. If the signs are the same, we subtract. If the signs are opposite, we add. So in this case, we're going to add all the way across. Now, working from left to right, the first one we have is x plus -x. And what is x plus -x? It would be 0. 1 plus -1 is 0. -2 plus 2, 0. Well, this is looking like the one we did or started the lesson with. What is z plus 4z? And lastly, -11 plus -9. You're good. So most of the previous ones, we ended up with an equation with 2 variables, yes? How many do we have here? Can I solve for that?
We could divide by 5.
Yeah, go on and solve. And z is? No, you're good. They're very easy to forget or drop.
That's why usually stuff that I'll say is because I don't write it down.
Yep. You're good. Well, that's nice, because if we do end up with one variable at this step, go on and solve for it. Now let's look at the other side. Now, if we look at the other side, so again, we're wanting to eliminate y. We eliminated it out of the first one. That was our goal. We ended up actually eliminating x and y. But here we want to eliminate y out. So what would we need to do to eliminate the two y's?
Oh, but they're the I did write that on my
Oh
paper.
shoot, I was looking at 3x.
I did write that on my paper again. I wrote it negative instead. I write it.
I have written,
I was looking at the.
as if the signs are the same, we subtract. If the signs are opposite, we add. Now, going from left to right, 3x minus negative x. Well, the negative makes a plus, so we have 4x. 2y minus 2y. 2 minus 2 is 0. 2 minus 2 is 0. Then we have negative z minus negative 4z. Would be negative almost. Because negative 1 minus 4.
Oh, sorry.
You're good. And again, these negatives, and especially how it's written, can sometimes be challenging.
I keep writing the difference of.
This is also part of the reason why I draw the same sign all the way through, just as a reminder to myself what I'm doing for each one. And the last one, 7 minus negative 9. Because we can always plug it in. 7 minus negative 9, 16. Questions on any of this so far? Well, doing one elimination for one gave us z equals negative 4. The other gave me an equation with two variables, yes? Do we know one of those two variables? Z, yes? Now we can just start solving. We'd have 4x plus 20 is equal to 16. What can we do next? By minusing it, we can move it over. We can get 4x by itself, because 20 minus 20 is 0. 16 minus 20 is negative 4. Negative 4 was right. And lastly, so x is negative 1. Now we just need to find the value of y, because it's the last part of the problem.
So do we just take the.
So at this point, we just need to pick one of them. Okay. We're just going to erase everything. Because we have negative 1 space negative 4. We just need to pick one of these three equations. It doesn't matter which, because this solution point, the x, y, and z that we're looking for, will all be the same. So pick one. Top, bottom, or middle? Middle. So we have 3x plus 2y minus z is equal to 7. We take this equation, I plug in the values I know. I know the value of x is negative 1. I know the value of z is negative 4. We plug them in, and then we're going to simplify. Our 3 times negative 1 is negative 3, plus 2y. Our negative 4 is going to become plus 4 is equal to 7. Combine like terms. Negative 3 plus 4 is positive 1. What can we do next? Move the 1 over by subtracting it from both sides. Telling us 2y is equal to 6. Yeah. Divide both sides by 2. Telling us y is 3. So our point is -1, 3, -4. So on a Cartesian plane, we can say this is z, -4, -1, 3, to be some point out there, kind of. Questions on any of this here? Questions on anything we've done so far? Yeah.
It's so hard to remember all of it.
So whenever you're here,
Like, you know it when you're here. Like, I remember all of it when I get here, like, do a problem. But when I go home, it's just like,
Biggest thing for these here, one variable at a time. So some of it, especially the prompting questions, are going to be helpful to remembering those, or kind of having an idea of what do we do first. Well, we need an elimination. Eliminate one variable first. We just need to pick one and go from there to the next step to the next step. Does that make sense? So instead of doing one more, I want y'all to go on and start on the homework. So if you do have questions, you can ask. And yes, there are only 5 problems. 3 through 5, 11, and 13.